In this video, we are going to learn how to implement a stack using two queues. It's a really interesting data structure concept because it's mixed with idea of LIFO and FIFO behaviors together. Let's break it down step by step and understand how to this work in the simplest way possible. Now, before we implement a stack using two queues, let's quickly recall what both these data structures actually are. So, firstly, we are going to look as a stack. As a stack, we have to a stack is a linear data structure that follows the rule last in first out concept. That means LIFO. It means the last element you add is the first one that comes out. As an example, just imagine just like as the stack of plates. You can only take the top of the plate on the from the stack plates, and you can't remove one from the bottom, and also you can't remove middle of the bottom. So think just like that. The operation in this stack we are using push, pop and pick. The push means add an element to the top of the stack. Pop means remove the top element. Then peak is view the top element. So now I explain how these are actually work. Now in this first picture they have two numbers. I got now 2 and 3. This is consist of first stack. Now I add number 9 to this stack 2 and 3 from the top of the in this input from last element. So in that they have 3, 2, 3 and 9. After I remove the last element I input, that is number 9. After number 9 they have 2 and 3. After again I pop the last element from that stack. Then I have only 2. Now we got the queue. A queue is another linear data structure, but it works in the opposite way: first in, first out. First in, first out. That means the first element you add will be the first one to be removed. So example, think of people waiting in a line at a ticket counter. The person who joins the first to that queue, he will be served first. The operations in this queue method is we are calling NQ and DQ. NQ means add element to the rear here. Then DQ means remove element from the front. Now I will show how that will be happen. This is our queue. The first one who enter the it means NQ. The one who entered the and then he after served from the service, then he removed from that queue. That is DQ. That we are calling that method is FIFO, first in, first out. Now that we are remember how a stack and queue work, then let's move on to our main problem for today. How can we implement a stack using two queues? The goal is implement a stack using two queues. Okay. Then this might be a bit confusing at first because these two data structures are already opposed principle have them. In the stack works with LIFO, that means last in first out operation, and while queue works with FIFO, first in first out operation. But with a little trick, we can actually make a quiz behave like a stack. Now we are going to use two quiz and we'll name them Q1 and Q2. This think of Q1 is the main queue, and that is where most element will be stored in Q1, and also Q2 is the helper queue used temporarily used to perform operation. Now we need to have implement stack properties from these two queues, like we have to implement push and pop method by using two queues. Our target is to make these functions work exactly like a normal stack, but now only have two quiz operation. Like we have to implement that stack using queue operation just like in queue and dq. So now the real challenge is this. In a queue, we can only remove from the front, but in a stack, we remove the last inserted element. So the question is, how do we get access to that last element using only queues? Okay, alright. Now let's start with how to implement a stack using two queues. Firstly, they have different two methods to implement this QueueStack. Now that is push friendly and pop friendly method. Firstly, we are going to how this push friendly method work on. The goal of push friendly method is very simply we have to insert a new element into our stack. But remember, since we are using two queues, Q1 and Q2, we can only use queue operation like in queue and dq. Now I draw in Q1 and Q2. Then at the start, both our queues are both empty. Now Q1 and Q2 we can call push 10. That means we are inserting number 10 into a main queue Q1 into our stack. Since there are nothing key here, we are simply in Q10 into Q1. Now you can see I push 10 into Q1. If we now call push 20, we include 20 into Q1 statefully, not helping with Q2. We can straightly add that in Q20 into Q1. And also we can push 30 after when we are in Q20. Okay, now we are going to this is the so for every push operation we just include the element into Q1. That is it. Pretty straightforward. Remember, the channel is not pushing. When we have to drop, we have to also pop the in this push friendly method. When we have to pop in this method, we can now in that next moment.